Okay, so now now that we've discussed how to find if series with all positive terms converge, we've also discussed now with the alternating series, which alternates negative, positive, how to figure out if they converge using the alternate series test. Now you might be wondering, like, okay, so where does this go from here? So this brings us to a new idea called absolute versus conditional convergence. So there's absolute convergence, and then there's conditional convergence. So we're going to talk about what those are, and why they're important, and what it has to do with this whole, like, sometimes the terms are positive, sometimes the terms are always positive, sometimes they're negative and positive. So let's go into writing mode. So let's write this down. So what is absolute versus conditional convergence? Okay, so absolute convergence is when, let's say you take the absolute value of your terms and it converges. Now, if your terms were already positive, that's the same thing, right? Do you get what I mean? Like, if the BNs were all positive, absolute convergence is just regular convergence. So this only really applies to alternating series. So you only make the distinction if some of the terms are negative, right? Because if they're already positive, the absolute value of them is positive too. Okay, so you only make the distinction if you're starting with something that has negative terms. So let's say you have something that has negative terms, like an alternating series. If you take their absolute value and they still converge, that's called absolute convergence. So let's say, I'll come up with an example. We looked at the sigma of n equals 1 to infinity of minus 1/2 to the n. Okay? If sigma n equals 1 to infinity of the absolute value of minus 1/2 to the n converges, then it's absolute convergence. So what happens if you take the absolute value of this? Oops, sorry, I put the absolute values in the wrong place. There we go. So if you take the absolute value of this, what are you going to get? Do you remember how this became minus 1 to the n, 1/2 to the n? So what happens when you take the absolute value of minus 1 to the n? It just goes away, right? Because the absolute value of that will just be 1, leaving you with just the 1/2 to the n. And what do you know about this? This is geometric and it converges. So the absolute value of it converged, which means that this absolutely converges. And I'm not saying that like a 90s person, oh, it absolutely converges. No, I mean it converges absolutely in the sense that if you take the absolute value of it, it still converges. So you only talk about absolute convergence because some of the terms were negative. We then got rid of all the negative terms and it still converged. That's absolute convergence. Conditional convergence, on the other hand, is when the original series converges, but when you take the absolute value of the terms, it diverges. So let's say you took the absolute value of all the terms, and it ends up diverging, but the original thing still converges. That's what conditional convergence is. Conditional convergence is. And just to let you know, if you converge absolutely, you will converge. So if you know that something converges absolutely, it definitely converges. So absolute convergence implies the original series converges as well. So So if you know that, if basically what I'm saying is if the absolute value of the terms converge, then the regular terms will have to also converge. So let's look at some examples of those. Example. Determine if the terms diverge, converge conditionally, or converge absolutely. So there's three options. You can diverge. They might converge conditionally, which means the absolute value diverges. Or you can converge absolutely, which means the series converges and the absolute value of the terms of the series converge. So our series here will be n equals 1 to infinity of, let's do -1 to the n plus 1 divided by 3n plus 1. Okay, well we know that this is an alternating series, right? The n plus 1 here tells us that the first term is positive. Right, so it's going to go positive, negative, positive, negative, positive, negative. Okay. Our bn in this case, just the positive part, will be 1 over 3n plus 1. Okay, so what we're interested in now is whether the absolute value of all of this converges. Okay, which is this. So if you're taking the absolute value of everything, the -1 to the n plus 1 goes away, right? Because what you have here is -1 to the n plus 1 over 3n plus 1 absolute value. Remember, you could do the absolute value of the top divided by the absolute value of the bottom. Okay, right? The absolute value of -1 to some power will just be 1. And then because your n is always bigger than 1, 3n plus 1 is always going to be positive, so the absolute value of 3n plus 1 is just 3n plus 1. So we're really interested in, does this converge? That is the sum of the absolute value of the terms. So we look at this and we're like, we can do the comparison test, right? We've talked about the comparison test in this class. Actually, what do we know about this one? What should we use for this one? Oh, I'll just say that we know that this converges. We could use the limit comparison test. The limit comparison test says you would take the limit of, let's see, what should we compare this to? We'll compare it to, let me think. Let's compare, so n would be less than 3n, which would be less than 3n plus 1. Okay, yeah. And then if you take the reciprocal, you now know that 1 over n, oh no, you wouldn't want to do that. That's not going to work. How about this? I'm going to tell you, I'm going to leave out the details. This diverges. Yes, it diverges. Okay, wait. Sorry. Ignore me for a second. I've lost myself in my head. Pause. I'm calling a pause before I go down another crazy rabbit hole. Let me stop for a second and think about this. Okay, everything is right up till the absolute value of the terms. And then I've lost everything. I'm feeling my brain grind to a halt, so I'm I need to like take a time out, otherwise I'm gonna like say nonsense. I felt it all of a sudden falling apart. I was like, and then I caught myself. I was like, no, I'm saying a lot of crazy things. Okay, so let's look. Okay, so we're looking at this. We want to figure out if this converges or diverges. Okay, we should do a limit comparison here. So let me just look up the details of the limit comparison so I don't like, screw that up. Because I feel like I'm just saying stupid things. Okay, so the limit comparison test says you can compare two different sequences, an AN and a BN. And if you get something that's not equal to 0, then they both converge or diverge. Okay. Looking at this, it looks like the harmonic sequence. It looks like 1 over n. So I'm going to say that my Bn is 1 over 3n plus 1. And I'm going to call my AN 1 over n, because I know that this one diverges. So if I want to take their limit of the ratio, did I do this right? Yeah, AN over BN. Yep, okay, cool. So I would do the limit of 1 over n divided by 1 over 3n plus 1. Which would give me 1 over n times the reciprocal of 1 over 3n plus 1 is 3n plus 1 over 1. Cool. If you look at that, that's going to give you a limit of 3. There we go. Now, because this was not equal to 0, that means my original series is going to do the same thing as whatever this series does. And we know that 1 over n diverges. Thus, my original series also diverges. So this does not converge absolutely. Why does it not converge absolutely? Because the series with the absolute value of all the terms diverges. So we don't know. All we can say at this point is that it does not converge absolutely. We tried to look to see if the absolute value of the... If we looked at whether the series of the absolute value of the terms converges, it did not. So it does not converge absolutely. Oof. I was saying the right things, I just was not able to find the words to say them properly. So I'm going to pause for a moment, because this is important. We don't know if it converges conditionally or converges at all yet. We are just able to say that it does not converge absolutely, because we looked at whether the sum of the absolute values of the terms converged or not. It doesn't, so it does not converge absolutely. Now we have to look to see if it conditionally converges or possibly diverges. So let's do that. So now the question is, we check to see if the terms converge conditionally or diverge. Okay, so now we need to look at the sum of n equals 1 of minus 1 to the n plus 1 over 3n plus 1. Okay, this is an alternating series, so now we can use the alternating series test. So what were the conditions for the alternating series test? All your terms have to decrease, and you need the limit of the terms to be equal to 0, yes? So let's first see if the limit of the terms goes to 0. So our Bn would be 1 over 3n plus 1. If you do the limit as n goes to infinity of 1 over 3n plus 1, that goes to 0, right? The limit of 1 over 3n plus 1, that goes to 0, so condition 2 is satisfied. Okay, now we need to check to see if the terms decrease. So bn plus 1. So let's do this. So we know that n would be less than or equal to 3n. Should be less than or equal to 3n plus 1. If you take the reciprocal, you get 1 over n will therefore be greater than 1 over 3n plus 1. The 1 over... Oh, okay, wait, no. Sorry. I need a better way to do this. Let's write bn plus 1 first. That would be 1 over 3 times n plus 1 plus 1, which would be 1 over 3n plus 5. And then what's bn? Bn would be 1 over 3n plus 1. Okay, yeah. This is our bn, this is our bn plus 1. So we need to figure out the relationship between them. If I distribute the 3, yes! Thank you. My brain is still getting crushed. So now we need to start with these two things. So looking at them, what do you know about 3n plus 1 and 3n plus 4? Which one will be bigger? The 3n plus 4. Okay, now if you take the reciprocal of them, however, what is going to happen? It's going to flip. This one is my bn is greater than bn plus 1, which is exactly what I wanted, right? So this proves what I wanted, that condition 1 is satisfied. The terms do get smaller. So what do we know now? Well, the alternating series test tells us that this series converges. If you converge, but don't absolutely converge, that means you converge conditionally. So this conditionally converges. Why? Because it converges on its own, but if you take the absolute value of the terms, it didn't converge. It only converges conditionally. Whew, okay, that killed me, sorry.